A zero matrix is exactly what it sounds like. A matrix made up entirely of zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0. A zero in all of the rows and columns makes a zero matrix, and it can be written as just zero. Most of the properties that apply to zero in regular arithmetic will also apply to the arithmetic and multiplication of matrices. However, some will not. We'll have a quick look at the ones that carry over. Things like a plus 0 is equal to a. This is assuming, of course, that the matrix A is equal to in size the 0 matrix. If A is a 3 by 3 matrix, then 0 is a 3 by 3 matrix for this to work. A minus A is equal to 0. 0 minus A is equal to minus A. A times 0 is equal to 0, assuming, of course, that the two matrices can be multiplied together. So these are some familiar ones that still continue to apply in matrix arithmetic. However, there are some familiar ones that do not apply. A situation where A times B is equal to A times C, where A is not equal to 0. Normally we would say if A times B is equal to A times C, then B is equal to C. I can't remember what this law was called, but normally what we would do is we would just cancel, the cancellation law. We would just cancel A and say that B is equal to C. However, this does not hold for matrices. Another one, A times D is equal to 0. If A times D is equal to 0, then A or D must be equal to 0. Think of two numbers that are not 0 multiplied together that give 0. You can't. One of them must be 0. But with matrices, this is not necessarily true. So we'll look at some examples to show why in matrices these laws that work for regular arithmetic don't necessarily work for matrix multiplication. So I've got four matrices, A, B, C, and D. A is 0, 1, 0, 2, B is 1, 1, 3, 4, C is 2, 5, 3, 4, D is 3, 7, 0, 0. We'll look at the first one. A times B is equal to A times C when A is not equal to 0. Why B is not equal to C. A times B. 0 times 1 is 0. 1 times 3 is 3, so 3 there. 0 times 1, 0. 1 times 4 is 4. 0 times 1, 0. 2 times 3 is 6. 0 times 1 is 0, 2 times 4, 8. A times B is this matrix, 3 times 3, 4, 6, 8. A times C, 0, 2, that's 0, 1, 3, that's 3, so 3 there. 0, 5 is 0, 1, 4, 4. 0, 2, 0, 2, 3, that's 6. 0 times 5 is 0, 2 times 4 is 8. So A times C is also equal to 3, 4, 6, 8. In regular arithmetic, we can cancel out the A's. We have the same thing on both sides. It would be as if we had, let's say, just like 2 on both sides. We can cancel the 2. But if we have variables in regular arithmetic, we learn in algebra, we can cancel it on both sides. However, with matrices, we can see that if we canceled this, we would be left with B is equal to C. And we can see that B is 1, 1, 3, 4, and C is 2, 5, 3, 4. And they're not the same. So therefore, this cancellation law does not apply to matrices. Now for A times D is equal to 0. Think of two numbers that are not 0 multiplied together to give 0. You can't. At least one of them must be 0. But with a matrix, A times D, 0 times 3 is 0, 1 times 0 is 0. 0 times 7 is 0, 1 times 0, 0. So 0 there. 0 times 3 is 0, 2 times 0, 0, 0 there. 0 times 7 is 0, 2 times 0 is 0. A times D is a 0 matrix, and A or D are not equal to 0. So this property of 0 does not apply to matrices or matrices.